Hello, my name is Holly Sutterall, and I am a student in the Masters of Science in Health Informatics program at George Mason University. This presentation was prepared as part of HAP823, a course on comparative effectiveness taught by Dr. Ronald F.A. Woodman at George Mason University in the Department of Health, Administration, and Policy. Today, I'll be answering the first question of week 2. This question may seem like a simple mathematical problem, but today I want to make sure you understand the background behind Logit and what it is and what it is used for in logistic regression. Before we go to Logit, we need to understand what a logistic regression model is. We use this model for different variables to determine the likelihood of an outcome. An ordinary regression is used to establish a model that relates to the probability of the outcome. If we have predicted values that exceed 1, we cannot interpret the predicted values as a probability estimate, since a probability function must range between 0 and 1. If there are probabilities above 1, they are meaningless and do not tell us much about the values. We need to make sure that the predictions are within the appropriate range. We need to regress the log of odds of participation on the predicted values. Log odds range from 0 to infinity, therefore there would be no problem of being out of range as seen in the probability function. So how do we regress log of odds? So once we calculate the odds of the participations, then it will be possible to calculate the probability of participation by a simple transformation. The response variable equation is called the Logit function of pi. As you can see, the odds function equals pi over 1 minus pi, and the response variable is a natural log of the odds. So a little bit more on the logic function of pi. It is a transformation that allows calculating binary responses from a set of predictors. So for example, if a patient was enrolled in the Medical Foster Home Program, or the MFH, the value would be 1. If the patient was not enrolled in the MFH program, the value would be a 0. Logic functions can always be called a link function, since they can link the independent variables to the transformed response variable. And if the analyst is interested in predicting the probability of the event, he or she can always do so by using the inverse of the link function. So how do we solve question 1, which is the logic of the probability of 0.75? First, we need to determine what the odds are. And in this case, we need to use the equation pi divided by 1 minus pi, and pi would be our number of 0.75, so that our odds is 3. And then our response variable is just the natural log of 3, which is 1.110. And the answer would be the logic probability of 0.75 is 1.10. Now that we've calculated the Logit probability, we can use it in an example. So this example, I will use what I talked about before, patients enrolled in the Medical Foster Home, or the MFH. First, we need to determine the logistic regression. It is used to predict the log of odds of participation, meaning we are predicting the transformed responses variable from n independent variables. And as you can see that the natural log of pi over 1.10 is the logit of pi. The logit of pi from the previous slide is 1.10. So once we have that number, we want to get the inverse of the logic function, because it is used to transform the predicted value to an estimate of propensity to participate. And we assume that the predicted value from the regression is alpha. And here, as you can see, the alpha equation looks just like a regression model equation. Lastly, we can now determine the propensity of participation in MFH program, or the medical foster program. Since pi is a probability function, the variance of the predicted values can be calculated as pi times 1 minus pi. The procedure allows us not to only predict the probability of the event, but to also calculate its variance, and thus be able to construct confidence interval around our predictions. And this is the conclusion of my Teach 1. I hope that you understand the purpose of the logic function and how we can incorporate it into regression analysis instead of just figuring out what the answer is and it's just a simple equation. There's a lot more than that number. Thank you for listening. Have a good day.